Okay, hey guys. This week we're going to do some review. We're going to start reviewing for the end of the semester. And we're going to go back and talk about quadratic functions. And if you remember that quadratic functions are polynomial functions of functions of degree 2. And what does that mean? That means the highest exponent is 2. Okay? So the shape of a quadratic function is called and you all know this, we've learned it, a parabola. Okay? The vertex is the highest or lowest point. So it's either going to be shaped this way, and we have a highest point, or it's going to be shaped this way, and we have a lowest point. Okay? And this is a vertex, and this is a vertex. All right. This should all be a review, but some of you may not have gotten it the first time around. So the AOS, which I like to call it, but it's really the axis of symmetry, okay, is the line that divides the polynomial in two. Okay, so if I have a polynomial that looks like this, it has an imaginary line that goes right through the vertex, and this is the AOS. Okay, it's always x equals some number a. Okay, it's going to be x equals some number a. The blank are the points where the graph intercepts the x-axis. The x-intercepts, okay, we also called them zeros and roots, if you remember. Okay, the y-intercept, and you know, I said intercepts plural. I'm going to change that up. It could be more than one. It could be just one, because it could actually bounce on the x-axis. Come down, hit the x-axis, and go back up. Y-intercept, and it should be intercept, not plural, is the point where the graph intercepts the y-axis. There will only be one intercept, if there is one at all, but there will only be one. All right. The roots, or zeros, of a function are the x values for which the value is for which the function's value is 0. So that means it's where y equals 0. Okay, called the roots or the zeros. Okay, when the vertex is the highest point on the graph, it is the maximum. Okay, it's the maximum value that the graph will take on. Meaning, okay, this is the max. It won't get any higher than that. The graph will not go higher than that. And if it's the lowest point, then it's a minimum. Okay? That's a min. I'm going to abbreviate it min for minimum. And if these notes look familiar, there are notes from in the semester. I wasn't going to recreate the wheel, but I do want to review with you. So if you didn't really get it the first time around, focus up. Stay in here with me, and we'll get it this time. Yeah, let's keep going. Okay, so this dashed line right here that you see, that is the axis of symmetry. Okay? And it's really important, the axis of symmetry, because all the points on the parabola are equidistant from that axis of symmetry. Here's what I mean by that. This point right here is 3, 0. I can count 1. Okay, I can count to the axis of symmetry. 1, 2. Now I count 1, 2, and here's my mirror point. -1, 0. These 2 points are the same distance from this line. Okay, really important point. Now, what we're looking at right here, here is the x-axis. Okay, and what's important about that is that this point and this point are the 2 points on the x-axis where the graph crosses it. If you notice, the y value of both those points is 0. Okay, so we refer to these type of points as x-intercepts. Okay, we also call them zeros, and the reason is because of the zeros in their coordinate point, and we call them roots. Okay, all functions have roots. All functions. Quadratics will have up to 2 real roots. They can have no real roots, but that's a future discussion. All right, keeping on here. We're going to keep moving my notes up just a little bit. So this box points to that point. That's my lowest point. That is my vertex. Okay, in this case, it happens to be a minimum. How come it's a minimum? Because this graph will never go lower than that point. It goes, as we go left on the x-axis, we go down, 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 hit this point, and then up, 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 up. Okay? So the graphing program we use does not allow it, but there really should be an arrow here, and there should be an arrow here because those graphs go on forever. Okay? Now, this box points to this point. And this point is really important because that point happens to be the y-intercept. Okay, the y-intercept, as you know, is where a point crosses the y-axis. It will always be 0 and some number b. Okay, and I put b in there because in slope-intercept form, y equal mx plus b, b is the y-intercept. Okay, so we have looked at 3 different forms this year of quadratics, all right? The first one is this one, standard form. The second one is this one, vertex form. We didn't really necessarily look at them all in these particular orders. And then finally, intercept form. Okay? I guess I should have written form here. So these 2 are my x-intercepts. A just tells me if it opens up or down, remember? Here we have ax squared plus bx plus c, which is the standard form of a quadratic. Okay? All equations have standard forms. This is the standard form for quadratic. A is really important because A tells us whether it opens up or down. Okay? C is important because it always, if you plug in 0 for x, C is the y-intercept. And I think you all remember these things. And then we had minus b over 2a and f of minus b over 2a to find vertex from standard form, all that stuff. This is vertex form, and if you remember, we learned how to complete the square to write it in vertex form. And A again tells me whether it opens up or down, x minus h, quantity squared plus k. hk is my vertex. So here my vertex is minus b over 2a, comma, f of minus b over 2a. Okay, so what we did in class when we were doing this was we took the b and the a and we put them in here and we got a number. Whatever number we got, we plugged it into our function and we got a y value. So we got an x and a y. This is my vertex. So b minus, oh, hang on, I'm getting ahead of myself. Here, my vertex is hk. Okay, here the vertex is a little different. you have to take and find the middle point of these two. So we don't, if I'm going to work with this form, I'm going to plot the x-intercepts, and then I'm just going to do the math, okay? So it's p plus q divided by 2, okay? And f of p plus q divided by 2. So if you want to know, it's going to be p plus q divided by 2 and f of p plus q. I wouldn't do it this way. I don't know. I just wouldn't. That's a lot of thinking. Okay. Now, as another review, let's take a look at this guy and let's talk about him, and we'll graph him. And we'll even make a table of values. Okay? So the first thing I want to know is, does it open up or down? And you say A equals 1, so it opens up. So we know the shape is going to be like this. Yeah? Second thing I want to know about this one here is I want to know what's my vertex. Well, I know my vertex is going to be HK. So is it 1 or is it negative 1? It happens to be 1 because when we pull it out of the parentheses, we change the sign. But K is negative 4. So we know that our vertex, this is going to be X, okay? This is going to be Y equal X minus 1 quantity squared minus 4. And then this is going to be XY. This is our table for finding values. One of the things I taught you this semester was when you learn how to find the vertex, you put 1 right in the middle of your table. Okay? Now, I'm going to put 1 right in the middle of my table. And what I'm going to do is I'm going to go up, down, and up. So 0, negative 1, negative 2. And over here, I'm going to write it in blue. I'm going to put 2, 3, and 4. Now, here's what I'm going to do. I'm going to clear my screen, okay? And I'm going to take my equation, and I'm going to plug 1 in. So what I'm really doing right now is this. Y equals 1 minus 1 quantity squared minus 4, which is going to be 0 minus 4, which is going to be negative 4. And I'm going to get 1, 4. 1, negative 4. That's my vertex. 1, negative 4 is right here. Okay? We said it opens up. It's down here, so we know that the graph's going to go like that. Now, what I'm going to do is go like this. And if you have one of these calculators, even if you have a TI-83 or a TI-30, you can do the same thing. But I'm going to go 1 minus 1, parenthesis, and then I'm going to square it, minus 4, and I'm going to get minus 4. That's what I have in my table. Now, the way I roll in class is a little different than some of the other teachers, as you may know. Some teachers will ask you to go like this, 0 minus 1 quantity squared minus 4 equal, and do all of this all the way around, okay? But here's what I'm going to do. I'm going to hit second enter, and you can do this on your TI-30s. You can use your arrow keys, okay? You can do second enter if it works. But I'm going to scroll back, and I'm going to change this to where X is 0. I'm going to put it in 0. And I'm just going to hit enter. And I know that when X is 0, Y is negative 3. You know what that tells me? By symmetry, I'm going to have the same point right here. These two are going to marry each other because of the axis of symmetry. So for demonstration purposes, let me take our graph here. And since I'm using color, I'm going to go right through my vertex. And I'm going to make an axis of symmetry line. Now let's practice. This is going through point 1, so this is the equation x equal 1. By the way, you're expected to know how to do that, okay? Because I've taught you. Now, what am I going to do next? Negative 1. So I'm going to take my calculator, and I'm going to bring the entry up again. Now, I have to be I have to think here because I have to insert it. So second INS is insert, -1 minus 1. See that? Then I hit enter and I get 0. So for -1, y is 0, which means for 3, y is 0. Now, one thing I haven't been doing is plotting my points. I have 0, -3, and I can go down here and go to 2 and come down, or I can just go like this, count 1, and I plot the point. You see my graph? Now I know that it's -1 and 0. I can count 1, 2, 1, 2. There's my graph, okay? And I'm going to do it one more time. And I'm going to change that from a -1 to a -2. And I get 5. So -2, 5, 4, 5. Look, work smart, don't work hard. Sorry to move that on you, but I wanted to clean it up. Work smart, not hard. I'm not filling in all of this stuff. And I don't need to fill in all of this piece, all of this. I don't, because I'm using my technology. But I did show my teacher, Mr. Sterling, that I know what I'm doing. Okay? It would have been good for me to go like this. 1 minus 4 equals -3. Do 2 for me, and I'm happy. Or if you want to, you could do these two and then leave these two blank because you're using AOS. I'm using the axis of symmetry to get those points. Okay, now let's plot our last 2 points. -2, 1, 2, 3, 4, 5, and 4, 5. I did it that way, but I could have done it this way. 1, 2, 3, 1, 2, 3, and there's my axis of symmetry. So, final answer for my graph is going to look something like this, and we want to make it look like it should. So, try to keep nice straight lines and then put arrows on the top. And you're done. Okay, so what we just did right here was we used vertex form. We first noted that A was positive because there's nothing there. So A is 1 and it's positive, which means it opens up. It opens up, okay? Then we identified the vertex. Then we put the vertex right in the middle, smack dab middle of our table. Even if you don't write everything out, I still want you to make a table of values. If you did what I did right here, I know what you did. I know you used your calculator, and I know that you used the AOS, okay? Really important to me that you show me you know what you're doing. Now, this is not vertex form. This is standard form. So we got to do a little more thinking on this one. This is P minus Q and P minus, X minus P and X minus Q. But I want to know, does it open up or down? And you guys are all yelling down, I hope. And how do I know it's down? I know it's down because of that negative right there. A is negative. All right. So let's do this, though. With standard form, what we want to do is take x minus 1 and set it equal to 0. And we want to take x plus 3 and set it equal to 0. I don't need the parentheses. Don't know why I wrote them. I'm going to add 1 to both sides. And I'm going to x equal 1, which means when x is 1, y is 0. Because if you plug in 1, you get 1 minus 1 is 0. Here you get 4. 0 times 4 is 0. I don't care if it's negative. It's still 0. So it's 1, 0. Minus 3 and minus 3. X equals -3, which means -3, 0. So I'm going to put a point there. And I'm going to put a point here. And I know it's opening down. Okay, I know it's opening down. So I know that my vertex is somewhere up above the x-axis. My graph is going to go through and through. Okay, now, since I know that the axis of symmetry splits points, I can count 1, 2, 3, 4. Ha! So 1, 2, -1 is my vertex. Okay, -1 is my vertex. So I'm going to go like this, equals the opposite of -1 minus 1 times -1 plus 3, and I'm going to get an answer. How am I going to do that? Am I going to do all that work? No, I don't like to work hard. I like to work smart. So I'm going to use my negative key, and I'm going to put a negative on my screen. Left paren, -1 minus 1, close paren. And then I'm going to do -1 plus 3. Oh, my bad. Left paren, -1 plus 3, close paren. Hit enter. It's 4. Which means -1, 4 is my vertex. And if you think about it, this is -2, and this is +2, and this is -1. So a negative times a negative is a +2, and a 2 times 2 is 4. There it is. Our vertex is at 2, -1, 4, my bad. Okay, so then if this is -1, this is going to be -2, this is going to be -3, this is going to be -4. This is going to be 0, 1, 2. Because I'm only going to go 3 above and 3 below, and I'm going to use symmetry. So, you know me, I don't like to work hard. I'm going to go like this. Change this to a 2, and change that to a 2 for my -2. So now what I have is -2 minus 1. Okay, so if I write it out, it's y equals the opposite of -2 minus 1 times -2 plus 3. And I'm going to hit enter, and I'm going to get 3. So -2, 3, which means this is 0, 3. Okay? All right. So -2, 1, 2, 3. My axis of symmetry, which I have not drawn in, would go right through my vertex. As soon as I have my vertex, it's not a bad idea to take your ruler out and make yourself an axis of symmetry. Always take the time to write down x equal, in this case, -1. Always take the time to write your equations. You'll always know how to write those equations. You will see them from now on in all your math classes. So I'm going to count 1 over and then 1 over, and there's my other point. Look at that. I have 5 points. At this point, Miss Sterling's like, you can use that in graph. Well, I already have -3. I know what -3 is. It's 0. And I already have 1. It's 0. So let's just do -4 and call it good. So I'm going to change that to a 4. I'm going to change that to a 4. I'm going to hit enter, and I get -5. -4, -5. So -5 is right here, and -4 is right there. I can count 1, 2, 3, 1, 2, 3. Now I can make my graph and call it good. And this is a review. So your homework on Math Excel is going to be about graphing and working with quadratics. Can you find the vertex? Can you find the roots? Okay. Thank you very much. Talk to you later.